Hi, I'm Stephanie Condon with ZDNet, and I'm here with Chris Robison, lead data scientist for Overstock.com. Hi, Chris. How are you?
Doing very well, thank you.
Good. Thanks for joining me today to talk about how Overstock has tackled machine learning. As we all know, retail has become a really competitive space where personalization has become a really big part of turning window shoppers into actual buyers. And I know Overstock is something is knows a lot about staying competitive. You guys have been around for almost 20 years. So I was hoping you could first, Chris, tell us a little bit about Overstock. Give us a quick primer. I'm sure we're all pretty familiar with Overstock, but how big the company is, how many customers you serve, what you sell, that sort of thing.
Yeah, absolutely. So like you said, we were founded in 1999. We're headquartered here in Midvale, Utah. Um, we're a large tech company, and specifically I work in our e-commerce arm in marketing. So we have roughly, 5+ million products that we're marketing on a global scale. And the very unique thing about our company that attracted me as a data scientist, data enthusiast here, is just that, almost 2 decades worth of rich data that we can actually mine. And that puts us in a very unique space in the e-commerce industry. And so what that amounts to for me as a data scientist and a marketer is years and years of rich web log data. So we're able to actually go back and look at some of our early customer profiles and individuals who were maybe young parents at the turn of the century who are now starting to shop for that first set of dorm room furniture for an excited new undergraduate student. And to see people through those actual transitions in life has been a really incredible data set and an incredible opportunity as a data scientist.
That's pretty interesting. And obviously machine learning is a pretty new area. Can you tell us a little bit about when Overstock decided to start applying machine learning to really make use of all this data?
Absolutely. And so specifically, I don't know of an epoch date for when Overstock decided to start using machine learning. I know that there have been varieties of algorithm groups and machine learning groups in Overstock throughout its history. We have a very strong analytics core here at Overstock, so it's been more of a nuanced and gradual progression throughout our history. But at our core, we have always been a very data-driven company. And I think that mentality of looking to the data and looking to strong analytics to influence our business decisions made machine learning, once the jargon word machine learning became very popular, a natural progression for us.
Where was Overstock in this process when you joined?
So I joined roughly 2 years ago, and there was a large data science group that was being formed in Overstock at the time. And so they were certainly showing a larger interest in machine learning and looking to incorporate data science and machine learning into every part of the company and the organization. And specifically, my realm in that has always been marketing. So a very important part of the business, but certainly not the entirety of where we're using data, analytics, and cutting edge engineering.
Now that's interesting because from what I understand, machine learning can be hard to apply at scale within a large organization. Can you tell me a little bit about the challenges when you say that you were tasked with, applying it throughout the organization? What are some of the challenges you ran up against?
So again, specifically my task was to apply it in the vein of marketing, but I think, there's similar challenges in any of these applications. And one of the largest challenges for, I think, anyone in the industry is that last mile of moving models that have been nicely honed by data professionals into an actual production environment. Mm-hmm. So that's where in marketing, we came to Databricks as a possible solution for that specific problem.
Interesting. So tell me why Databricks was the good solution there.
So my team in particular was using an open source computation engine called Apache Spark. Databricks as a company was formed by some of the original creators and founders of Apache Spark, and they're currently pushing back the vast majority of open source contributions to the Apache Spark project. So it was a natural fit for the tool we were using, and then looking at a managed platform that could help us, I guess, productionize and accelerate our innovation using that tool. And so certainly not the only solution in the industry. It's the one that worked well for us in the marketing group.
Mm-hmm. So can you tell me a little bit about exactly, what kind of models you were building and what you were learning from your customers?
Absolutely. So the first task that my direct team was given was to identify propensity to purchase out. And so the idea there is we'll, comb over this weblog data that I talked about kind of early on in the interview, and try and develop feature designs that help us identify when a customer is, say, just window shopping, to use kind of the physical term, versus when they're actually ready to convert. And so how do we encode features, including, classic time series, lead and lag variables, all the way up to event interactions that show us when someone's ready to kind of pull that trigger and make a purchase.
Interesting. When you talk about event interactions, can you tell me a little bit more about what that means?
Yeah, so really an event in my world is any action on our website. So anytime you go and click on maybe a different color swath for a couch, or you're viewing a product page, anytime you enter the site, those end up being individual events in our weblog data. And our job as data professionals is to take that very disparate data and roll it up into something meaningful in terms of feature design. And so some of the interesting things we found were, first off, confirmation of natural assumptions. People tend to browse and window shop more often during the day, and may be more likely to convert in the evening. There's also a lot of interesting cross-device interaction. I for one do a lot of browsing on my cell phone, but if I'm making a large purchase, say, a sofa or a coffee table, I'm more likely to do that at home on my actual computer or a tablet. So different interaction points that show us, is someone really gearing up and ready to convert? And one of the more interesting ones we found were people tend to use their cart like a wish list. So people will add different items to their cart. Maybe they have the same couch, but it's in different color patterns, or very similar couches that are all mid-century modern, but they're trying to find that exact fit that they want. And then individuals will go and start to remove items from their cart in a monotonic fashion, which signals to us, they really are getting ready to convert because they're trying to meet that budget that they've set for themselves. And so seeing very interesting nuanced patterns in the exploratory phase, and then trying to encode those as we're building models and trying to improve on those models' performance.
Cool. Can you tell me, first of all, I'm curious how you go about collecting all of these signals. How do you collect and organize and store them? Is it hard to gather, all these millions, I would assume, data points coming in?
It is, and we're a large company, so we do have multiple data sources. So as we're looking at multiple data sets and trying to aggregate those together. The interesting issues come up, like identity matching, things of that nature, trying to figure out, as people move from device to device, are they the same people? What assumptions can we make there? But it's a very difficult problem. And more importantly, it's difficult to do at scale. So, there's sort of two phases. In the exploratory phase, I might have enough time as an individual contributor to go through and, join across different data sets and get a nice data representation that I can use. But then trying to automate that process as we move models into production is an entirely different story.
Mm-hmm. And what is it? Why, can you explain more about why moving models into production is such a difficult process?
So a lot of the time is the difference in environments. When I came to Overstock, a lot of the data scientists were running models and doing computations on individual machines or inside of Jupyter notebooks, things of that nature. And so being able to then take small sample data sets that you're prototyping a model on and figure out how to get that model so it's in line with a marketing process, say pushing particular bids or propensities to a channel, tends to be very different. Then you're interacting with production databases, production environments. We need to come up with automated ways that we can ETL the data and get it rolled up into the format that we want. But there also needs to be checks and balances on top of those processes. If things are running in an automated fashion, in particular, as these models move more towards real time, there's a lot of opportunity for processes to kind of get out of control and run awry. So you need monitoring, you need checks and balances. There's always data validation processes. If the fundamental behavior of our customers changes, maybe for a reason in the market, or because, for example, this time of year, we're heading into our peak season with Black Friday and the winter holidays, that's going to fundamentally change the distribution of any of my features. And so we need to have monitoring set up for that. So one, we notice the problem before it becomes any real issue, but then it becomes a more interesting question of, okay, has the behavior of our customers actually changed, or did something break in my automated ETL process? Mm-hmm. And we need to be able to answer those questions very rapidly.
So can you tell me a little bit more about kind of the business strategy you're trying to advance with these models? How does this, once you determine whether a customer is about to make a purchase, for instance, what happens next?
So on the marketing side, we would push that propensity to purchase into, one of many different bidding algorithms, and then decide to very actively bring that customer back to our site or attract that customer, if that makes sense. So a lot of it in the propensity to purchase sense is a retargeting play.
Okay. And you might do that through emails or notifications, things like that?
Yep, exactly. Really, any of the various marketing channels that we have to utilize. Mm-hmm. It's important to remember everything we collect is from customers, and we're collecting that information based on customers who've actually opted into hosting our cookies on their browser. Mm-hmm. And we're getting information pushed back, and we can aggregate that with our actual on-site information.
And have you seen any results from these initiatives in terms of, converting customers?
Yes, absolutely. And a lot of the results are being closer to the actual interaction point of our customers. So originally when we started out with this propensity to purchase algorithm, the way we moved from POC to kind of what I would call phase one was doing a daily update. But then we quickly realized as we were working with our product managers and business partners, if I'm pushing a propensity to purchase once a day, I could potentially be 24 hours away from that customer's interaction, which in e-commerce is a lifetime. Mm-hmm. And so trying to get closer and closer to that customer's interaction point. So maybe if they're browsing on their lunch break, we can be retargeting them by the time they're at home in the evening and ready to purchase. Or, as we move more and closer to real time, maybe we can actually catch them on that next break and show them some display ads, or send them an email that they'll notice that will remind them of what they're looking at and bring them back to the site.
Right, yeah. And I wanted to go back to something you said earlier. You were talking about how Overstock has this unique trove of data that goes back, almost 2 decades now. I'm curious whether you can leverage that extensive data collection for this particular marketing goal.
So that's a very interesting question. For this particular marketing goal, because kind of customers' behavior and patterns tend to be have a fairly short-term memory. Some of the older data may not be as relevant, just because the way that customers interact with e-commerce websites has fundamentally changed. I mean, online shopping, especially in the last 5 to 10 years, say, has become so ingrained into our day-to-day lives that those patterns and signals are really starkly different from maybe the early enthusiasts about online shopping that were coming to our site in 99 or 2000, when the original website was still written in C, and looking for those early deals for us as a large rug retailer. So those patterns have certainly changed, and people, for lack of better words, are just much, much more comfortable with online shopping.
Absolutely, sure. What can you tell me a little bit about what can you learn from that old data?
So that's where it gets into more of our customer-centric or CRM database. We can actually look at these patterns of, historically who has been shopping, who have we attracted to, what does the longer tail nature of our core group of customers look like? Where are they in terms of demographic data that we might be able to get from the census or different third-party platforms? So it becomes sort of what I would describe as 10,000-foot view, whereas for propensity to purchase, we're at maybe 10 feet. We're right there looking at those patterns as they're coming through day over day, really at this point, minute over minute, and second over second, and trying to identify when those changes happen.
Interesting. One thing I wanted to ask you about also was the challenges of managing a team of data scientists. I've heard a lot about how it's a really competitive space. Have you run up against challenges with recruiting?
I think whether it's data science or traditional engineering or data engineering or the fantastic ETL professionals that we have here in the building, there's always a challenge with recruiting. The tech industry as a whole is so competitive and everyone is vying for the best and brightest. And so we certainly have similar problems with that as anyone in the industry would. I think one advantage that we certainly have is, Salt Lake is a very unique place to live and work. We have fantastic access to outdoor resources. Where I live, I'm a 30-minute drive away from 5 or 6 world-class ski resorts. We can climb in the summer, we can ski all winter. We have 5 national parks in the States. So a lot of our play to differentiate ourselves from maybe other tech hubs is the outdoor lifestyle and the quality of life that we have here in Salt Lake.
Cool. And what about collaboration? Is that a challenge for your team?
Overstock as a whole has an extremely collaborative culture. We're still a very face-to-face company. A lot of my friends that are in the industry are working for companies that are almost entirely remote. The majority of our employees are here in a single building in Midvale, so we're able to collaborate constantly. And it's a necessity to be able to have success in Overstock.
Cool. So it sounds like you've had some success so far using machine learning for projects like determining when a customer is about to make a purchase. Mm-hmm. Can you tell me a little bit about your next initiatives?
So I think in terms of my next initiatives, I've actually recently transitioned to be Director of Data and Audience for the marketing group here at Overstock. So no longer a lead data scientist, but we're looking at how to take this platform that we built out in marketing and really deliver to our customers the messaging that they need to see when they need to see it. And that's what it's all about. It's not necessarily driving an individual towards the quickest purchase, because that may not be the best thing for us or them. It's figuring out, are they in the exploration stage of their journey? Are they in the research phase? Do they really know that they want one specific chair, but they're trying to decide between different tones of wood or different fabrics, and making sure that we're giving the messaging that they need based on their kind of spot in time and space.
Interesting. Cool. Well, Chris, thanks so much for your time today.
Yeah, thank you very much. I appreciate it. It's been a pleasure.